Let's start. So, hi everyone, we are Roland and Charlotte. We were interested in our modeling in factors affecting your sleep quality, and in particular about the influence of the gut microbiome. Oh, doesn't work. So we'll give you some background, talk about our model and the connections that we made adaptive. And we did several experiments that we will also walk you through. So let's start with, when you sleep. So your sleep timing is determined by your internal clock that regulates wakefulness and sleep. And you have a period of 24 hours, and this is all driven by a region in the brain called suprachiasmatic nucleus. This brain region regulates several things like your body temperature and secretion of the sleep hormone, melatonin. And this wake-sleep cycle, production of melatonin, they are all regulated by the day and night cycle of darkness and light. And it turns out that the microbiota found in your gut can also affect this sleep-wake cycle because of this bidirectional connection between brain and gut. And this connection consists of neurotransmitters, hormones, immune system, the metabolites that the bacteria produce. And also there's a connection between melatonin, which can affect microbiota behavior, and the microbiota in turn can lead to changes in melatonin production. Now, the microbiome itself is also affected by many different factors. To name a few, it's affected by the food you eat, how much stress you experience, and whether you take any antibiotics. So based on these connections from the literature and a few more, we built this model of, this is the base level of the model. And we have incorporated the light and dark, the circadian rhythm, which regulates the sleep and wake cycle. This state represents whether the gut microbiome is balanced. It's called eubiosis. We have included this cytokine from the immune system, whether you have infections, and factors like stress and exercise. Then we also made a first adaptation level. There we made some weights adaptive. So the first one is the weight from psychological stress to infection. And this weight is affected by the sleep quality. And that's because we know that sleep disruption will increase your susceptibility to infection. The second adaptive weight is the one from healthy food to sleep quality. And that's affected by eubiosis because we have, when the gut microbiota are imbalanced, so when the balance is disturbed, it can lead to issues in nutrient uptake from your food by the gut. So the effect that food can have on the rest of your body is now smaller. And the third adaptive weight is psychological stress to sleep quality. This depends on sleep quality itself, because the better you sleep, the lower the responsiveness to stress becomes. Then we also have an adaptive threshold, the one for sleep quality. And that's because your body has this certain equilibrium. And whenever a disturbance occurs, for example, if you experience stress, that doesn't necessarily mean that your sleep quality is greatly disturbed. So the effect should be strong enough to overcome the threshold. And the height of this threshold is determined by several things. So we included the light-dark cycle, the immune system, circadian rhythm, sleep quality, and the state of infection. And we make this threshold for sleep quality adaptive. And we use the logistic combination function for this. Okay, the first simulation that we did was the scenario of a healthy person. So someone who eats healthy, has low stress levels, has no infections, is not taking any antibiotics, and has a high amount of exercise. And we can see from the simulation, it behaves as we expect. So this blue line represents sleep quality. The sleep quality is very good. The quality of the circadian rhythm is good, and of the gut balance in your gut microbiota, whereas the negative states of our model, like stress and infections, all go down to 0.
Okay, so in the next experiment, we thought about maybe adding jet lag, which is changing the initial values of our light dark hours to 0, from 1 to 0. So in this situation, we can see that our sleep is disturbed a little bit, but then it stabilizes. This is because after a time, our circadian rhythm will compensate for that sleep and dark cycle, and will eventually make us sleep even better. Next. In here, this experiment is basically the same healthy person, but with an unhealthy diet. Healthy food is now the function that is used for healthy food is the identity function. So whenever we have a very bad food intake, we modulate, we change that to 0, and the best quality of food, like really healthy food, is at 1. So here we change the initial values to 0, and we see that there's an effect on sleep, an effect on our eubiosis, it's the stability, and also the stability of our circadian rhythm, and our state of IL-6, which is our immune system, also it's changed mostly. Next. So in this experiment, we also wanted to try to see what would stress levels, like psychological stress, do if we had them at maximum. Until now, in our healthy person, we had it 0.2, which is less than average, but is somehow low. It's not super stressed. Like, we are not always stressed, but there's no person in the world that doesn't have stress. So in here, we can see that although sleep is not really changed, we see that this is mainly due because of our threshold, which is not achieved, like we talked before. But we can clearly see that IL-6 levels are high enough, and also the stability of our circadian rhythm is a little bit changed. Next. So now towards physical exercise, there's something that we wouldn't expect, right? So here, when you like we expect it. Sorry, we expect this because whenever we don't have any physical exercise, we will suffer. Our body will suffer, and that threshold, if repeatedly we don't exercise, it will change, and our body will capture that. So our sleep quality will be less. And forget about these two lines of X9 and X10, we forgot to remove them. This actually don't have any weights towards them now, but we can clearly see that IL-6 is affected greatly, which is expected, right? So it's a suboptimal level of IL-6. And also our eubiosis decreases a little bit. Now for bacterial infection. So in this we have we made the model for 2 weeks, and we expected like whenever we have an infection, that infection can last up to 2 weeks or more, or even depending on the incubation state of the bacteria or the virus. But we are not modeling virus yet. So here we have we made 2 scenarios with antibiotics and probiotics. And here we can see that whenever we take antibiotics after infection, our sleep decreases in the beginning. Our sleep quality decreases in the beginning, but then stabilizes, which is good, right? So then also we can see that our eubiosis will eventually recover. So this is very interesting in our point of view, which might be why our sleep also goes back to normal. Next. So after considering some aspects, we also wanted to try what would happen if we took antibiotics and probiotics at the same time. So we made a simulation for also 2 weeks where we, of course, we cannot take antibiotics in one day and then just leave it there. Like you should take at least 2 antibiotics per day in order to have some effect. So as you can see, and clearly is something very particularly interesting, is that after some time, our immune system reacts towards stabilizing this sleep pattern, which happens that this sleep quality, sorry. So we see that our sleep goes down, but then the stability is provided might be probably because of the immune system, or even our eubiosis state, which is achieved. Next. So we wanted to test that, and we made it for more than 2 weeks. We made it for 4 weeks. So this is what happens. It's we can eventually really prove that it stabilizes, but the sleep quality remains high. It's good. Next. So for further discussion, we still don't have a conclusion to this project yet. We are still working on it, but we would like maybe to do in the proximal future some second order adaptation, probably stress decreasing the adaptation speed, or maybe just in order to model viral infection better, model its speed too, because some bacterial infection is something really fast, but viral infection is something that incubates for longer time, so we need to have more time to see this effect. Maybe we will try to verify these outcomes with real data, but it's really hard to find real data out there, but we can make some suppositions from the literature. Maybe add some seasonal influences towards night and dark, and our well, states. And yeah, this model has so many possibilities that I don't think we have the time to finish everything now. So so this is it. I think it's a very good model towards exploring more and more. If you are really curious about what the outcomes might be, this is the best model to do it. Next. Thank you. And any questions?